Hello, my name is David Berrigan, and I'm a program director and researcher at the U.S. National Cancer Institute. Today's plenary, Putting Cancer in Its Place, Geospatial Approaches to Energy Balance and Cancer, is for the second International Electronic Conference on Environmental Health Sciences. I was really excited to get this invitation to speak at a virtual conference because I had recently been at an international conference in Prague, and there was an extensive conversation about the ethics of international travel during this era of climate change. So I'm hoping that virtual conferences might prove to be a complement and a supplement to conferences that require travel and its incumbent carbon footprint. I work at the U.S. National Cancer Institute's Division of Cancer Control and Population Sciences, and our mission is really to take a preventive and population approach to reduce cancer risk, incidence, and death, and enhance the quality of life for cancer survivors by supporting innovative research. My work is focused on promoting and extending efforts to understand environmental influences on behavior and risk. I define environment broadly to include both the traditional toxic environment, air pollution, for example, but also the built, natural, social, economic, and digital environments. This perspective is gaining traction in the U.S. and worldwide with a flurry of editorializing. For example, the director of the National Institute of Minority Health and Health Disparities at NIH, Eliseo Perez-Estable, wrote a recent editorial addressing health disparities is a place-based issue. And the distinguished Harvard professor Nancy Krieger wrote, Follow the North Star, Why Space, Place, and Power Matter for Geospatial Approaches to Cancer Control and Health Equity. So the theme of this work is to try to address places and their influence on health, as well as individual disease and behavior. In the next 15 minutes, I will highlight research and challenges related to mapping, cancer control for specific places and spaces, cross-cutting issues, and some challenges in the application of geospatial thinking to health research. This talk is a bit like a top 10 list of restaurants in TripAdvisor. You'll get some ideas from this talk, but to really see if any of this research is going to make a good meal for your research agenda, you need to read some of these papers like you would go eat at a restaurant. NCI has a history of mapping that has predisposed us to an interest in spatial thinking. We've been steadily investing in high quality and more granular data about cancer incidence and mortality to try to identify public health problems and help formulate etiological hypotheses about cancer. These three maps illustrate the distribution of oral cancer in women in 1975, 1987, and 1999. And you can see by 1999, it's become increasingly clear from the red areas of the map that are highlighted that oral cancer is more common in women in the southeastern United States. People realized that this was also a region where women were more likely to use snuff, and this led to a series of hypotheses and additional research on how the use of dipping snuff is related to increases the risk of oral cancer. More recently, increases in colorectal cancer in people under 50 have received a lot of attention, and these increases are hypothesized to be linked to the increasing rates of obesity in the U.S. Here we illustrate that with a map of colorectal cancer incidence over time in males and females, and you can see increases between 1995 and 2015, and a corresponding map of colorectal cancer incidence by state, where the highest incidence in these younger adults occurs in areas with a greater prevalence of obesity, suggesting further work on the link between obesity and early onset colorectal cancer is warranted. Most of today's talk is US-centered, but many of the ideas and lessons here can benefit from global perspectives. For example, reciprocal research and conversation about cervical cancer mortality between the US and worldwide cancer researchers is leading to ideas about needs in under-resourced populations. Here you can see higher levels of cervical cancer mortality in poorer regions of the U.S., in the southeastern areas, and patterns of cervical cancer mortality worldwide, suggesting that it's under-resourced countries that are experiencing higher mortality rates. So now I'll touch on three themes concerning cancer control for specific places: rural areas, digital aspects of rural health, and cancer center catchment areas. Here you can see emerging disparities in lung, colorectal, and HPV cancer in the rural U.S. in this panel of graphs plotting cancer incidence over time for rural and urban communities. This widening gap between urban and rural areas is the result of a complex mix of compositional and contextual influences. We need more sophisticated conceptual and analytical approaches to defining the rural-urban continuum. We need to evaluate program and policy experiments in particular contexts, and we need to develop creative, spatially and contextually informed interventions. So geographers are wanted for this kind of research. One potential explanation for this involves the digital divide. There's a lack of access to communications in rural areas of the U.S., and this may be associated with less knowledge and less capacity to identify and use resources. We're supporting work aimed at testing the idea that broadband access, coupled with other resources, could reduce rural health disparities. And I think this is a neat example of where we need to pay attention to both the built natural and transportation environments and the digital environment to try to advance public health. In both urban and rural areas, we have a renewed focus on cancer center catchment areas. Here you can see the Norris Cancer Center and the area it serves in New Hampshire in the northeastern U.S. The colored bands around the cancer center reflect different travel distances to the cancer center. So we need to acquire, aggregate, and integrate data from multiple sources to try to understand and improve how the center is delivering services to these catchment areas. We need to conduct local research to better define and describe the cancer center catchment areas using multi-level population approaches. And we need an area-based focus rather than a disease-based focus if we really want to address health disparities across space and across time. So this attention to the catchment areas, we hope, will move us in that direction. The next theme of this talk involves discussing some cross-cutting research areas that call out for collaboration between geographers, environmental scientists, and health researchers. Small populations, evaluation of natural experiments, exposure assessment, and enhancing behavioral interventions are the themes I'm going to mention. Demographic, geographic, and social factors create small populations, which then, for a variety of reasons, are the source of many health disparities. The challenge of generalizability has resulted in inadequate research to address these aggregate disparities arising in small populations. The complex diagram on the right of this slide illustrates a flow chart that can help you decide whether you have a small population issue or some other kind of problem, such as a rare disease issue or a hard-to-reach issue. This diagram is available in Srinivasan et al., AJPH 2015, and it's an open access article. So many critical small populations are characterized by specific and complex geographic areas, and I think this is something that health research could benefit from geographic attention. Second, diverse programs and policies potentially influence cancer-related health behaviors and health services. These sorts of natural experiments can have a profound influence on health, but they're not amenable to randomized trials of their effectiveness. You cannot randomize transportation systems or often new economic opportunities. So we're advocating and trying to support research aimed at evaluating natural experiments and improving these longitudinal study designs to enhance causal inference. In this example, Tamara Dubowitz investigated the dietary consequences of a new full-service supermarket opening in a food desert in Pittsburgh. This sort of research has a set of characteristic spatial challenges. defining the relevant area of the community that might be influenced by the supermarket, defining which people in the community might be using the supermarket, inference from activity and use patterns, and understanding the resident behavior over both space and time. These sorts of challenges apply to myriad topics in health services, transportation, green and built environments, and other aspects of the community that might influence public health. A key to understanding behavior and risk involves accurate measurement of exposure. Here I'm illustrating some work by Marta Jankowska, also influenced by her collaboration with Peter James, trying to contrast static exposures. What kind of exposures do you experience just around your home with dynamic and activity dynamic exposures, where you try to examine exposure in people's entire environment over space and time, for example, tracking them with GPS systems and linking their activity space to GIS data layers or individually worn sensors to try to recreate a more realistic picture of exposure. Best practices to integrate these data layers are not yet settled, but this is an exciting area of research. Related to the move from static spatial analysis is a renewed push in cancer epidemiology to account for time. Traditionally, only one or a few addresses have been used for respondents in epidemiological cohorts to try to recreate their exposures. Now we're trying to focus on residential history to try to understand the long-term history of exposure and exposure during critical windows of vulnerability over the life course. This sort of thing can involve self-report, linkage, and commercial data sources. There's a valuable chapter from Peggy Reynolds in Berrigan and Berger's 2019 Geospatial Approaches to Cancer Control book, and that chapter presents lessons learned from the California Teachers Study. You can see in this diagram, which I urge you to take a look at in the book, that it can be a complex process to try to integrate these different data streams to recreate residential histories. Additionally, there's some tools relevant to the United States at the website listed on this slide. Nevertheless, after reconstructing residence history, data layers about exposure and activity space remain challenges. So you need both a reconstruction of history and a reconstruction of the environmental characteristics over time that were present in those different places. These two aspects of exposure assessment, space and time, are integrated in Mei-Po Kwan's Uncertain Geographic Context Problem essays. She attempts to talk about the challenge of understanding which environmental context might be relevant to exposure, behavior, and health outcomes. So this is an attempt to integrate dynamic exposure and temporal aspects of residential history or work history. This kind of thinking has its roots in classic work such as that summarized and extended in Parks and Thrift's book, Time, Spaces, and Places, a Chronogeographic Perspective. Essentially, can we improve inference about environmental causes of disease and health with more complete data on location and exposure over time? So people have been talking about this for quite a while, but I think this remains the top challenge in the application of geospatial thinking to health research. Lastly, there's a lot of excitement in behavioral research about just-in-time adaptive interventions. Just-in-time adaptive interventions involve contacting, pinging, or intervening with someone when they're at a vulnerable moment. So this is relevant to geospatial thinking because imagine a person walking by a Dunkin' Donuts. At that moment, they might be tempted to change their diet. And if you could somehow ping or encourage them at that moment, you might be able to help improve their health behaviors. So there's a pressing need in this context for more dynamic, place-based theories of behavior that can help us understand decision points, decision rules about intervention options, and how to document the proximal outcomes of these JITIs, just-in-time adaptive interventions. Shani et al. In 2018 have an elegant paper describing some of the challenges in this area. Lastly, I want to talk about a few challenges that persist in realizing the potential of geospatial approaches to cancer control. First, privacy is a profound challenge here because someone's home or work address allows you to identify them, and if you're studying health, you may well be studying sensitive health or behavioral characteristics. So protection of privacy is a top priority in this kind of research. There are multiple approaches at present, all of them aim to try to protect confidentiality. At NIH at present, investigator-specific access is probably most common. Each researcher owns the data, receives agreement from their subjects, and analyzes it themselves. This is great, but limited since it prevents data integration across multiple studies. For some federal surveys, often we have contractor-held data resources, so the contractor protects the confidentiality. Again, this can limit data sharing. For federal health surveys, federal research data centers are available where you can analyze federal surveys like the National Center for Health Surveys data resources or census data. However, lack of standard protocols for IRB and access to data have limited data sharing. Additionally, global variation in rules about data protection, for example, the EU General Data Protection Regulations, are limiting cross-country data sharing and collaboration. So this remains a pressing problem in increasing the power of our analyses. This is a diagram of a system that allows HIPAA-compliant analysis of confidential data in an Amazon Web Services space. I won't go through the details of this diagram, but it points to the fact that we need more than just health research expertise. We need data science expertise to try to improve our capacity to share and protect confidential health data. Until recently, there's been a lack of collaboration and expertise across these different fields that could lead to economical turnkey systems allowing better data sharing. But I think this is changing, and I hope in the coming decade we'll see a greater and greater capacity for data linkage and analysis. Finally, a top problem for environmental data is dimensionality. To fully describe the built, natural, social, toxic, and economic environments, you might require hundreds or thousands of variables, and it can be difficult with conventional statistical techniques to try to extract meaning from data sets containing such high dimensional variables. The traditional approach to this problem is data reduction, looking for a few dominant factors with principal components analysis, factor analysis, or other statistical techniques that explain some or most of the variation in the hundreds or thousands of variables that you've collected. Whedon et al.'s neighborhood archetypes analysis is an example of this, and we continue to learn from this approach, but there's a fear that by aggregating data, you're missing the specific influence of single important variables. An emerging approach to try to address this problem involves neighborhood-wide association studies. Based on genome-wide association studies, this is a statistical tool to pull out particular influential variables from amongst a large number of neighborhood characteristics, or in the genome-wide association studies, from a large number of genes. We're excited about this approach, but only a few papers have attempted to use it so far for environmental data. Lastly, a few products that I alluded to earlier, but I want to highlight that we're pretty proud of from NCI include this book, Berrigan and Berger, Geospatial Approaches to Energy Balance and Breast Cancer. 2 CEB focus issues, one on rural cancer control and one on geospatial approaches to cancer control, and the proceedings of a workshop held at the National Academy of Sciences, Improving Health Research on Small Populations. So I commend these resources to you. In conclusion, I call for advancing geospatial research for cancer control by continued focus on place and health, learning from maps, further attention to small populations, a focus on rural and other place-based cancer disparities, better exposure assessment via residential history and contemporary examinations of activity space, continued efforts to address the persistent challenge of privacy and efforts to increase opportunities for data linkage and analysis, and more statistical and analytical work on dealing with the high dimensionality of environmental data. The citations in this talk are listed at the end of the PowerPoint presentation, and you can obtain this entire slide set either, I think, downloading from the conference, or simply send me an email, David Berrigan, at berrigad@nih.gov. Thank you very much.